everyone, welcome back to another episode of our operating system series for gate preparation. In the last video, we talked about deadlock avoidance, specifically the banker's algorithm. Today, we are shifting gears to deadlock detection and how to recover from deadlocks when avoidance is not possible. Deadlock detection ensures the system periodically checks for deadlocks and recovery involves strategies to resolve them when they occur. Let's dive right in. Let's see what is deadlock detection. Deadlock detection involves periodically checking the system to see if any processes are stuck in a deadlocked state. This technique is used when deadlock prevention or avoidance is too restrictive, allowing the system to operate normally until a deadlock actually occurs. Unlike deadlock prevention and avoidance, where we periodically ensure deadlocks do not happen, detection lets the system run as usual. The system then periodically checks if any deadlocks has occurred, allowing more flexibility at the risk of handling deadlocks later. Let's see how deadlock detection works. Detection mechanism use resource allocation graph or algorithms like the wait for graph to detect cycle which are inactive to deadlocks. A cycle in the RAG implies a set of processes that are waiting for each other, forming a deadlock. Deadlock detection relies on graphical tools like resource allocation graph or algorithm like wait for graph. These tools detect cycle within the system and a cycle suggests that deadlock has occurred. Let's look at an example to understand this better. Imagine three processes each holding one resources and waiting for another resources which is being held by another processes. This forms a cycle of dependency which is detected by the system using the resource allocation graph. Once a cycle is found, we know a deadlock has occurred. Let's see what is deadlock recovery. Once a deadlock is detected, the system must recover by breaking the cycle. Deadlock recovery technique includes terminating processes or preempting resources from the deadlock process. After detecting a deadlock, we need to recover from it. The two main recovery techniques are terminating one or more of the deadlock processes or preempting resources from them and reallocating these resources to others. Let's explore these methods further. There are two ways to resolve deadlocks. Process termination means we can either terminate all deadlocks processes at once or terminate them one by one until the deadlock is resolved. And resource preemption. Alternatively, we can preempt resources from deadlock processes and assign them to other waiting processes, breaking the cycle of dependency. In a situation where P1 and P2 are deadlocked while waiting for each other's resources, the system can either terminate one process to free up resources or it can preempt one of the resources and assign it to the other processes to break the deadlock. To wrap it up, deadlock detection helps us identify when a system is a deadlock by looking for cycle, while deadlock recovery provides techniques to resolve the issue by either terminating processes or preempting resources. Combining these techniques offers flexibility in managing system deadlocks. If this video helped you understand deadlock detection and recovery, give it a thumbs up. Subscribe for more gate content and leave a comment below with any questions or topics you would like us to cover next. Thanks for turning in, everyone. In the next video, we will dive deeper into memory management in operating system. So be sure to stay tuned, keep practicing, and let's continue this journey to crack gate together.